we basically have one more presentation left, which is I'm really excited about this one. So a good friend of mine, Tyler Odenthal, coming to us from Roboflow, is going to talk about his OBS gesture controller. He's using computer vision. I really, really wanted to have these guys on the show today because to me, having computer vision is going to change this industry in a lot of different ways. And Tyler's going to show how computer vision can be used to automate an entire production and really kind of make you the director of your show just by he's going to be doing like peace signs and up symbols, and he can even control a source in OBS with his hand. It's like Jedi mind tricks.
It is.
So I'm really
definitely
excited to see
curious
what
about
Tyler's
this.
up to. I know he's been working really hard on some of this stuff,
Let me see
and
if we have Tyler yet.
we've got he's still got 3 minutes, so we'll give him. Robbie wants to see the ceiling.
All right, Mike, could we get a ceiling shot?
That's actually, that's something that we don't show enough, and I'm gonna let Mike do it because if I use this IR remote, I think he's gonna be mad at me. Let's see.
Yeah, don't use the IR remote.
Oh yeah, I'll let him do it. Yeah.
Oh goodness, you're getting more questions. Is
Okay.
TikTok being banned in America? I have no idea. Where in the chat is the link? I will resend the link. Can you convert a Zoom webinar to a Zoom meeting while live? Or does Zoom events allow both of these styles of meetings depending on the room?
Okay. Yeah, I can answer that question. So we specifically set up, excuse me, our Zoom event to have a webinar and a meeting. So we're not going to be converting those. We're just going to, they were designed for specific reasons. But I noticed that if you schedule a Zoom meeting or a Zoom webinar and you have a webinar license at any time before the event, you can convert it. I'm not sure if you can convert it during the event, but we were hosting a webinar last week and I was looking at it and it said, would you like to convert this webinar to a meeting? And I said, no, I don't want to click that button. But I could see maybe wanting to, I guess.
Yeah.
In certain cases.
At least the option's there.
Tyler's here. Hey, Tyler.
Hey, guys.
Thanks for joining.
It's great to have
of course.
you. I was just giving a little intro for you, Tyler, and telling everybody that you're going to use computer vision. It's kind of like magic. Most of our audience is video producers, and many of them have their own businesses. They do live streaming and video production for their clients. But I'm going to guess that computer vision is a first. And for me, it was. I got connected with you, Tyler, and you said, hey, we could use this Roboflow thing to create a computer vision model and we can control OBS. And I was like, that's pretty cool. Let's try it. It seems like you've taken it 10 steps further than that. But yeah, that's kind of where we kind of got connected, huh?
Yeah, definitely. I'm very passionate about the capability of developing an AI producer. So OBS is, the main streaming application for a lot of Twitch streamers and YouTubers. So I was very intrigued with the capability of adding AI to, OBS. And, with your insights, it was really cool to know that OBS has a WebSocket feature, which allowed us to combine computer vision with OBS controls. So I'd love to talk a little bit about that today. And I have like a small presentation going over some of the things that I see, computer vision influencing as far as video production goes. So, happy to jump in. And I also have like a little demo as tweaking it as we were, getting ready to do this event. But I'm good to go and happy to share some insights.
Cool. That sounds great. I'm glad you have the blue screen glasses on because you're going to need them.
Yeah, no, definitely. I recently got glasses, so I really like them for, how much work I do on the computers and such.
Cool. We'll take it away.
Cool. Would you just... Yeah, cool. I'll just start sharing my screen and quickly jump into my presentation. So Here, I'll move this over. Cool. So this is my little intro to computer vision, AI camera controls. So for those of you who don't know what computer vision is a field of artificial intelligence that allows computers to interact and understand the world around them. There's many types of computer vision applications out there today. Some of the most common that you're probably familiar with is self-driving cars, like Cruise or Tesla. But I'm going to dive a little bit deeper into some of the ways that computer vision sees and some of the other applications that, you might see if you watch sports, but didn't really know that was computer vision that's, operating all those things. So let's dive into, the different types of computer vision, because computer vision is expanding pretty rapidly. Maybe 10 years ago, we were really focusing on classification, which is essentially the process of taking a full photo or a full video frame and essentially trying to analyze what is in that video frame with one label. There's also another type of classification called multi-label. But the main idea is that we want to take this whole frame of input and then classify it as one thing, like a cat or a dog or, a color. So classification is like the lowest level of computer vision. And then your mid-tier level of computer vision is called detection. So detection is a step above, because essentially it doesn't just take that whole image and break it into one classification. What it does is it takes that image and it looks at the regionality of the image and it tries to detect the objects that are inside of that image. So you can see for this example, there's a cat and there's a dog, and we're able to draw the bounding boxes around the cat and the dog with localization. So that's called detection. And then at the highest form of computer vision at the moment is called segmentation. So segmentation works by wrapping these polygons around the object. So essentially it's like object detection, but you get even more regionality data inside of that. So essentially you can get very tight knit boxes around your objects, which might be very important for, 3D modeling or for manufacturing use cases. If you're trying to look at the size of a whole and you want to know that it's really uniform, segmentation is something that you would need to do that. So these are kind of like the baseline types of computer vision. So before you even start a computer vision project or, start trying to get gesture controls into OBS, you got to figure out the problem. So essentially, what is the problem that you're trying to solve? For OBS or video production, in general, that is a pretty time-consuming project. So if you imagine you're trying to shoot a video play, like a screenplay, you might have multiple cameras. You might have someone who's a producer who's actually in charge of knowing which camera that we're supposed to be focusing on, zooming in. And you have kind of like a guideline for what you want to try to solve for. So we need to first identify the problem that we're going to be trying to solve with computer vision. And I have a couple of fun little examples before we dive into more of the serious ones. So one of the more fun examples with computer vision is that there was someone specifically in the Roboflow ecosystem who had critters that were coming to their garden. And essentially they wanted to know what was stealing their strawberries. So the problem statement was someone or something in my backyard is eating my strawberries. And then the project statement would be, I need something that can detect and deter things from entering into my garden. And then the result was they trained an object detection model with a camera and a noise emitter and a tiny like water gun to essentially target the critters that are coming to their backyard and then try to emit noise or spray them with a little bit of water to make them run away. So this is like it's a funny application, but it is a very powerful thing that you can build with computer vision. And then combining that with, a PTZ camera or a noise emitter. So yeah, the use cases for computer vision doesn't have to be like at the highest echelons of technicality. It could even be as simple as, trying to detect, raccoons from entering into my garden. And then expanding that up back into, the live production space. Imagine you're trying to do a video production and you have multiple cameras, you're on set. let's say you're doing a live action shot of people running across a sidewalk and like it's a chase scene. Well, in that chase scene, you're probably going to have, you might even have like a aerial drone. You might have multiple cameras that you need to shift to. So how do I produce a high quality live stream with limited resources? So a lot of YouTubers and Twitch streamers, they don't have the capability. Well, I mean, some of them do, but most of them don't have the capability to hire a production team, right? So how do you get that level of production, or, you know, like an indie film type level of production, without, you know, the resources to buy that? Well, you can potentially use AI and computer vision to help, you know, monitor the cameras and transition from camera to camera. You can also, with the drone, there's a lot of projects that are working on object tracking and flight patterns of drones to essentially keep objects in frame. So I personally believe the end result, with this problem statement, how do you produce high quality streaming productions with limited resources? The end result's going to be an AI producer. It just kind of makes sense to me that, you know, once when you have this AI that can, you know, access multiple cameras, maybe it can recognize specific gestures, maybe it recognizes specific facial features when, you know, an actor is like crying or something, maybe it automatically pans and zooms in. So the result is a AI producer that can log these gestures. It can have multiple cameras that it switches to, and then it can provide analytics on the back end that says, hey, I noticed, you know, this gesture for X amount of time, and I did this feature. Like I zoomed in on their face because I felt like, based on my previous rule set, that this would be a good, you know, footage to capture at this point in time. So that's where I think it's heading. So what would an AI producer actually look like? So I think the top 5 optimizations that an AI producer could help with is, you know, that first one, object and person tracking. So essentially, as you have someone running, you want the drone to not only capture high quality footage of that person running, but you also want them to be, you know, tracked, like potentially autonomously. You know, in current days, we have drone pilots that literally are paid, you know, good money to essentially do these high quality commercials and high quality, you know, video production shots. But in the future, maybe that's done via, you know, AI. And then, you know, I was talking about content aware zoom. So essentially recognizing what's happening in the scene, and then being able to pan and tilt and zoom into that specific area of interest. As it relates to me, I'm currently working on a project that's focused on wildlife, and we have a pan tilt zoom camera that's up in an osprey nest, but the ospreys aren't always there. So you need to be content aware that sometimes the ospreys aren't going to be there, and that isn't going to be very highly engaging content for our users. So essentially what we've done is we've created a kind of like a camera network that says, if ospreys are not at the nest at this point in time, maybe you need to transition to the camera that's on the ground near the bay, because maybe there's flamingos at the bay at this point in time. So essentially that leads into step 3, which is automated scene priority. When you have multiple cameras that are set up, you can create AI logic that creates automated scene priority. And we kind of already see this in OBS to some degree. OBS has the ability to do automated scene transitions, but it's kind of based on whether or not someone is in the screen. But we can take that even like a step further with detecting the types of actions that are in that screen. So if you're imagining like a live streaming event where there's potentially multiple events going on at once, we can create a AI rule set that says, hey, we want you to transition from scene to scene with the intent of capturing the footage that has the highest engagement. So essentially you could have one camera that doesn't have a lot of good content that's going right now, or you can transition to the camera that has, you know, good content that's being captured at the moment. And then, you know, extending upon that is gesture recognition. So before you can create that rule set, you're going to have to be able to detect certain aspects of that scene. So maybe it's someone that's crying, or maybe 2 people are having a really highly engaging conversation. You're going to need the AI to essentially be able to capture that type of integration, or, you know, that type of content. And then at the highest level of optimization would be actual real-time video augmentation. And there are certain use cases today that are starting to do that, which I'll tap on a little bit in the future. But literally, if you could have your AI producer, or you could have a software that in real time, as you're capturing this footage, maybe it does scene transitions for you. Maybe you're scheduling an ad break. Maybe it needs to chop up some of the footage in real time and create like a collage so you can fill that ad break, right? So at the highest level, I envision that there's going to be some form of real-time video augmentation where you just captured this highly engaging content, but you might need to go to a break. So therefore you can stitch together all of this producer level types of features in real time via the AI. So it's kind of all the types of stuff that a producer would normally do. But you can create rule sets behind it and help expedite that process even faster. And then bonus would be ChatGTP. I don't know if any of you guys have played around with ChatGTP, but ChatGTP is very, very good at answering basic level questions at the moment. And I think it's only going to get better and better. So let's say you did need to go to that ad break. You could actually ask the AI and you could be like, hey, I need to schedule an ad break for 30 seconds. Can you chop up some footage for me? And then the natural language processing integration would then be able to take the previous footage that I just captured and then maybe create a highlight reel in real time. And I could see this being very, very important for, sports use cases. So yeah, those are the top 5 integrations / optimizations that I see the AI producer role filling kind of right away. So where are we today? So what is actually being applied out in the real world today? So what we have in the real world today is things like Project Runway. So Runway ML, if you go to runwayml.com, they figured out that the problem statement is video editing is really hard and it's time consuming. It takes a long time to edit your videos. Even, YouTubers and streamers have figured this out, that they need to hire editors pretty much full time to essentially take their long form content and break it up into short form content, because it takes them too much time to generate that short form content. So Runway has created tools like the magical AI tools and real-time collaboration, precision editing, that allows you to essentially, maybe you need to generate a photo, maybe you need to create that automated highlight reel that I was talking about. Runway ML is offering solutions to essentially expedite that process and get it into your workflow as fast as possible. And then the MLB actually engineered this for the strike zone. So if you've ever watched a Major League Baseball game, the problem is the umpire is human, right? The umpire is just like us. They're bound to make mistakes. So how do we know at like 99.9% of the time when a pitcher throws a strike? And the MLB invested in a technology called Pitch FX, which takes a multi-camera array, kind of like I was talking about with like the AI producer type concept. They have one that's top above the pitcher's mound. They have one that's like directly in front of the pitcher's mound, and then they have one at home plate, which essentially triangulates the ball in real time to get pitch trajectory. And then you can have, the cool thing is that they're even going a step further and they're doing real time, data augmentation. So essentially, like when that pitch is thrown, they not only have the simulation of the ball leaving the hand and going to the pitcher's mitt, but they can actually pull that up with video editing. So like essentially this real-time simulation is generated through the Pitch FX software, and it allows them to when they need to go to an ad break or fill a little bit of time, they could just pull up that graphic in real time and be like, hey, this is what the ball looked like, and it was a slider and it broke at this speed. And essentially they have autonomous graphics that get integrated into the every single Major League Baseball game. So that personally, I really, really like the strike zone, the Pitch FX use case, because it is a great example of how computer vision can solve a very complicated problem. And it's being used at the highest levels of entertainment. So it's a really, really cool use case to dive into. And then as well, on the entertainment industry, we have the NFL. So the NFL, if you've ever watched a football game, this yellow line is automatically generated. It is put there via a computer vision model. And essentially it says, when a user passes this line, it can send a little notification to the referees. And it's very intelligent at, placing this line, even when even when the camera is panning and tilting, that line is established by the computer vision model. So, how do you know when someone passes the 10-yard line? Well, the NFL solved it by making a computer vision model that can essentially place a line on the field and know autonomously when users pass that line. So this graphical system is called First and 10. And it's a really cool application of computer vision being used in the entertainment industry as well. So I'm gonna quickly transition over to the demo time. I was hoping to fill out maybe another 5 minutes with my presentation, but things go a little bit fast, I suppose. So what I'm gonna do is I'm gonna quickly stop sharing my screen, and I'm gonna transition over to a quick gesture controller demo. And then that will be the end of my presentation. So what I'm going to be doing quickly is I'm going to be pulling up OBS. And then I'm going to be turning off this camera because I need access to this camera. And what we're going to be demoing is the ability to transition between OBS using gesture controls. So we can do scene transitions, and we can also...
Mike's not...
Is my mic not working? Here. And we can quickly share again.
This here.
Cool.
There. Okay, there we go.
Now we are back. So now I'm in OBS, and I have an index file, which will open up Roboflow, which is our computer vision software. And I'm going to start this virtual camera. Cool. So now for my demo, you can see that I have Roboflow running. Oh, well, it's already going. So this is kind of cool. Cool. We transitioned back. So what we have going here is Roboflow is running a computer vision model on the back end. And what I've done is I've connected Roboflow to OBS. So I have two cameras operating at the moment. I have my DSLR camera, which is behind my computer screen. And then I have a PTZ optics camera that is kind of sitting over to the right of me. And what I'm going to be doing is I'm going to be attempting to transition between scene and scene using gesture controls. So here I'm going to quickly transition over to the PTZ camera. And excuse me, I am moving houses. So what we saw there was I used the down gesture, which was trained using Roboflow, to essentially transition over to my PTZ camera. And then I'm going to use the up gesture to transition back to my first camera. So we're just going to do that again real quick. So down and up. So we are easily able to transition between our first camera and our second camera. And what I'm going to quickly try to do is I'm going to transition back to my PTZ camera. So we're going to go back over here. And if the model wants to cooperate, cool. Yep. So what I'm doing is I'm using the grab gesture now to essentially move my PTZ camera to my face. So essentially in real time, I can attempt to use the grab gesture to move my PTZ camera. And it looks like we're going a little bit out of focus. So what I'm going to do is I'm going to use the stop command to essentially go back to home. And then we're going to try it again. So let's do the grab. Let's go back up. Cool. Come on. I just want you to go to my face. And let's go over this way. And we are good enough. So I'm going to quickly look at the camera. Cool. Hello. So yeah, we were able to use gesture control to essentially transition between scenes, as well as, go back to home. So we want to go back home. Here, how about we go? Let's go back to camera one, and then let's make it go home. Cool, cool. And let's go just back to camera one. But yeah, that's my demo of using gesture controls to essentially control a PTZ camera. There's obviously a lot more things that you can do with it. For a previous use case, what I did was I had it track. Goodness. I had it track my cats in real time. So essentially you could use the same grab feature to track my cats, going back and forth on, in the living room, and essentially using the same exact grab functionality. It was able to quickly, pan, tilt, and zoom on my cats. But yeah, that's kind of the breakdown of the basics of using gesture control to control a camera. But if there's any questions, I'm more than happy to, answer questions and try to fill up the last couple minutes of this segment.
That was so cool. I was like blown away by the computer vision models that you're working on. We were joking over there with the grab function to have it move to your face. It's like, careful, he's gonna hit himself in the face if he gets to go. Oh yeah. But no, that was really cool. And let's talk about some of the cool computer vision solutions that you guys work on, because I know they span the gamut. There's so much that this technology can do.
Yeah, definitely. So we see that the entertainment industry is very, very bullish on computer vision applications at the moment. So I know I already highlighted the MLB use case and the NFL use case. But if you imagine tennis for a second, right? So tennis goes back and forth. You have a volley and it's really, really high paced and really fast. So we've been at Roboflow tasked with the project of not only tracking the balls and the players, but also, creating simulation data, right? So like as the ball is going back and forth, same as the MLB, right? You want to get the trajectory of the ball. You want to know where it lands. So Roboflow has had the great opportunity to work with a group that's working with the US Open with tennis. And that's a really cool project that we've been doing recently. As far as other video production type aspects, I can't really think of them off the top of my head, but we do have a ton of conservation projects. So essentially, trying to track wildlife, when, fish essentially are feeding, fish feeding events, bird feeding events, tracking abnormalities and, animal behavior, all sorts of stuff. You can essentially name any industry and Roboflow is doing something with it. Manufacturing use cases, so detecting anomalies with manufacturing parts, kind of just runs the gambit. So if you're interested on any more specific industry, I can definitely dive deeper into that. But yeah, computer vision can be applied to any industry for a wide array of problems.
Yeah, and it's one of those things that it takes a while to wrap your head around what it is, and then what it can do for you, right? And so for me, it took me a little while, and you told me that we could control OBS, and I was like, oh, that's pretty cool. And then I realized, so basically, if the camera can see something, you can train the computer vision model to detect it. So
yeah,
you can see it. You could do something with that information, right?
For sure. I think a lot of computer vision projects start with that exact mentality, right? Like if I as a human can see, a fish that's feeding in the pond. Why can't I train a computer vision model to, detect the fish in the pond? Or, the same with, self-driving car use cases, right? I think it started in sci-fi, where it was kind of thought as like this mythical idea of like, what if we had self-driving cars? And then some scientist came along and was like, you know what, we could mathematically determine if this frame data has a car in it. And then it just kind of goes from there. So like any type of like wow that out idea that you have, as long as if the human can infer that situation, like, whether it's like bird species, or, like what color of car is this, or, how fast is the ball traveling in the air, like, as long as if a human can estimate that, or, determine classes, we can train a computer vision model to do the same.
Yeah, and I think a lot of our audience, we're video producers, we're live streamers, and I was discussing with Sam Kokojo from the Zoom team. He does all the Zoom events, and I was like, you really got to tune into this computer vision presentation. It's really interesting stuff. And I was like, think about it. What can it do for you? One thing that a lot of video producers, it's the bane of our existence, right? Is like keeping someone in frame, like in the center of the frame. Because what happens a lot of times is you've got all these widescreen cameras, and if I'm leaning over here, that's okay. I'm still in the shot. It's okay. But what happens a lot of times is they'll do like a 3-box shot where there's like 3 squares for the talking squares, right? Or 4 of them. And then suddenly, like, people aren't in frame, or someone's half cut off on the side. And we were talking about maybe computer vision could move things. And I think with enough programming, computer vision can be adapted to, if you can notice that there's a problem on video, computer vision models can be trained to identify it. But then there's this other side of the world, and at Roboflow, you guys call it inference, then what, right? Which is the ability to, you've got your computer vision model. Now, what do you do with it, right?
Yeah. I think you're totally right. Like for specifically video production, object tracking is obviously one of the top requirements, right? Like, how do you keep a person in frame all the time? I used to be a stage actor in college. So if you imagine like tracking, even the spotlight tracking, right? Like spotlight tracking can be autonomous via AI, right? Like if someone's like this close to the edge on the screen, we need to pan the camera to keep them in frame. Otherwise, they're going to go off the edge of the frame. So yeah, logic like that can easily be programmed into a computer vision application. So it's more so about like what types of aspects do we want to build into this AI application? Like is object tracking like high priority, or like do we want to do autonomous scene transitions, or do we want to add in some functionality like when a actor does a specific facial movement, like do we want to zoom in? All of that type of logic can be built into AI. So it's a really, really cool concept to start exploring, which is why I'm really happy that you guys are looking into it. It's a very exciting field to be interested in.
Well, Tyler, that's all the time we have. It was really, really exciting to see what you're doing and get a high-level overview. It's really the best place to get started with computer vision is to just watch some presentations, right? Start doing some YouTube videos. This is a big concept, and it's going to take time to wrap your head around how to apply it into video production. Tyler gave us some really good examples, but I do think it's not just going to be for the MLB. I do think that regular video productions are going to start using computer vision in some really interesting ways. So with that, it's time to jump into our networking session. So we are done our presentations. We're going to go into an awesome networking session, which is my favorite part of every StreamGeeks Summit. And then we're going to do a giveaway. Someone's going to win the Studio Pro camera. And then we're going to do an IRL stream with live view. So that's it for our webinar. Mike's going to switch over to the meeting room. Tess has already got it on our laptop, so we can pop it open right here and start chatting away.
If anybody's looking for some help with how to get to the networking room, if you're on YouTube, you will have to be registered for the Zoom event. Once you are in the Zoom event,
Yes.
When you are in the lobby, you will see there's 2 rooms. There's the main event room and then the networking room. Within the lobby, you're going to enter the networking room for the duration of the event. Unless you're, just going to stay watching live on YouTube, then you can hang out there and participate in the chat.
Awesome. A test. You might create an audio loop if we go through that. We should really go through Mike's thing. So let me walk him through that real quick.
Okay. I'll just hang here for now.